We go. Yesterday was the flap all the lips and front load all the information. This is how the class rolls. This is where the website is. This is where the resources are. Great, we got it out of the way. Now we're just going to hop into it. Okay. So chapter 0, I do like that about the McGraw-Hill books. Chapter 0 is the review. This is all the stuff that you should have encountered and should be proficient in walking into this room. But you know what? Summer Alzheimer's is a thing. You get a little bit of the rust on the gears. Maybe it's been a year since you were in a math class. Who did their Algebra 2 first semester last year? Okay. Earlier. Okay, good. Because that's really bad. It's been a while. So we're going to review. It's not long. It's just a couple of days of, hey, this is stuff that you should know walking in here. And then we move into the new stuff. Even that, it's not really new. It's more like expanding what you had before. When we hit chapters 1, 2, and 3 are expanding on stuff we already know. Deep dive analysis on the functions, the nonlinear functions you learned in Algebra 2. When we hit chapter 4, okay, now it's all new. Chapters 4, 6, 7, and 10 are all new stuff. I'm prepping you for the next 3 classes. Okay, so we start with review and then expansion. Round 1, sets. First of all, we'll see how bad Frank is. Yep, Frank's pretty bad. Okay. For anyone who has never been here before, we call Frank Frank. Come on. Right. We call the smartboard Frank because once upon a time, I had a young gentleman in my class named Frank. Frank was a senior in pre-algebra for the 4th year running. Needless to say, Frank was not very intelligent or cooperative. Henceforth, my smartboard shall be Frank. Because, God, I hate this thing. But we got to use it. Okay? So, everyone got the notes? You picked up yours from the back? Okay. Good to go then. A little bit of notation. Set notation. Because right away when we jump into chapter 1, we're talking about domain and range in terms of sets. A set, collection of things. You use those little squiggly brackets on here. Who here has really terrible handwriting? Like, you know, my handwriting's sketch. Okay? So when you're making your brackets here, can't even see that. When you're making your brackets, if you can do them like that, yeah, cool. If it looks like a kind of just a like sideways butt cheek, as long as I know it's not a 3 or an E, you're good. So don't worry about, I can't make the brackets. Don't worry about it. Okay, but it's a collection of objects that go in this set of brackets. The thing about sets is that you have subsets. You have universal sets. Kind of like the Russian nesting dolls. Y'all see like the original Toy Story, you know, the big bulldog that opens his mouth and the little guy comes out, and right? A subset is a group of things that goes into this other group of things. For example, in here, if I said, picture day, people wearing dresses is a subset of kids in PreCalc, right? Is a subset of students in the building. So it's just a collection of objects, and you use different notation for it. One bit of that notation, an element of. So this might be, I don't know what you saw and where you saw it, because the last year and a half has been trash.
Please send students from the freshman class with the last names E through M to the Commons. Again, E through F.
This
To the comments. Thank you.
is element of. You notice it kind of looks like a little sideways goofy E.
Can I have one of those packets of them with your
Boo. If there's ever anything that we have handed out, it's always going to be in those that little folder next to the door. It's in the one labeled PreCalc. It's the one that says 01 on it, like we're doing. Okay, so if Olinda is an element of set A, I have to write it in that order too. That's important. I can't do this. I can't spell. Okay. My ability to spell flatlined in 4th grade. Okay. I can math with the best of them. I can't spell. That I, E, and C rule is trash. I remember that I remember it wrong. Okay, that's just funny. Okay. I can't flip this around. This says Olinda is in this group. I can't say this group is in Olinda. Too much information. All right, we'll explain that joke to you when you're older. So use set notation. In each one of these, I just want you to write it as a set. I want you to tell me if their statement is true. So when I say n is the set of whole numbers greater than 12, less than 16, I'm going to write that as n, label the set, is set brackets. What numbers go in this set? Y'all can read. Follow the directions. What numbers am I talking about?
12, 13, 14. Greater than 12 and less than 16. So it would be 13, 14.
Uh-huh, right? If I asked, all right, how tall are you? Are you taller than yourself? No. It doesn't work that well if you're wearing heels or something, right? So I have to start at 13 because it says greater than, not greater than or equal to. 13, 14, 15, less than 16 means I have to quit there. Whole numbers. Ooh, do we remember our whole or our different number sets, our universes, our realms of sets?
So if it's whole numbers less than 16.15, then 16 is still.
It's just 16.
Yes, no, that's a good question. If it said whole numbers less than 16 point something, 16 would qualify because it's a whole number less than that. Yes, very much. Okay, and then I ask, is 15 an element of n? Yeah, so I'll just say true. Okay, I would like you to do the same for the next 3. Our veterans already know this. In my room, when I say, okay, here's the thing, I want you to do it, I do not want this room to be quiet. I want you talking to each other. I want you arguing with your neighbors. I want you calling out there, dude, not even close. Or, wait, what? Why are you have that whole equation and I got nothing over here? I want you talking about it. Okay, go, those 3. Oh, for vowels, Wheel of Fortune rules, y is a constant. Okay.
And this is set amongst them.
Oh, and for part D, assume a normal D6. It does just say a die, and that's not fair. A D6. Oh, and I didn't say this yesterday. Y'all, I know that you don't use your lockers and you carry around your life in your backpack. If you could please keep that not in the aisles, not in my little lap here, because I am incredibly uncoordinated. I don't need obstacles on top of it, because, you know, you trip, you accidentally get that graze, and then you end up on CNN.
Wait. Why are you doing that? No, I was just reading. I don't understand this. I don't understand.
Y'all good over here?
Yeah.
The cheese stands alone? All right. Normal D6. Sound like we're about there? Okay, V is a set of all vowels. The vowels. It should look like the phonetic pronunciation if you kicked a guy in the nethers. A, E, I, O, U. Oh! Is G an element of V? No. Is G an element of this set? Is G in this group?
So why'd you put that?
False. Okay. M is a set of months beginning with J. So we've got M labeled as a set notation. We got January, February, March, April, May, June, July. Okay. And in there, I'm pretty sure April is not in that. So, false. Okay. It may be a duh, but the idea is just to remind you of what set notation looks like. X is a set of numbers on a die. It does, you can tell they don't play D&D, okay? Like, I got D6, D4, D8, D12, D10, D20. Just, there they are, okay? So that's why I specified it's D6. Otherwise, this might be a little bit different. Technically, a coin is considered a D2. So, we have X is 1, 2, 3, 4, 5, 6, or the Munchkin head if you're playing Munchkin. And yeah, I'm pretty sure that's in there. 4 is on normal D6. Okay. Munchkin's a fun game. You get to like suit up your character, different races and classes. Like you can wear the horny helmet, and it's got like pictures. It's all puns on D&D. Like, yeah, it's good stuff. You can do the card to like you hire a halfling to carry around your stuff, and then later you can kill him to survive combat. You like, huh, kill him instead, and run away. It's great. Okay. Those cool beans. All right, here we go. Universal set. Universal set is the set of everything. All things. All objects. All objects are possibilities. Now, even the universal set can be defined. I could define my universal set as every student of Spearfish High School. And then my subsets go down from there. I could define my universal set as all teenage students in the Spearfish zip code. How would that change it? Do we have some that are homeschooled? Do we have some who are at alt school? Do we have some who live in the Spearfish zip code, but they open enroll somewhere else? Do we have some on Black Hills Online? Okay, so the way you define your universal set matters, but it is all objects that you're talking about. A subset Yoink.
Give your attention, please, for
No.
the next set of freshmen.
Subset is a group
N through F.
within that set.
Please report
So,
to come.
yes. We got a smaller group or collection that is an element of that universal set. Complement. Notice the E in there, not an I. This isn't the flurry of compliments that are rolling around today. Oh, I love your shoes. That's a compliment. This is a complement. Complement is something that goes with, a companion of, or in this case, the opposite of. Okay. Opposite of. So for example, if I said right now, I'll just throw a bunch of numbers in here. Where's green? There's green. 1, 2, 3, 4, 5. Right now, if I asked for the opposite of B, I could write it two ways. The book writes it as B prime. I don't like that because we've seen that notation elsewhere. Do you remember where? Where have we seen that little tick mark up there? Prime. Transformations in geometry. Remember when you'd have triangle ABC reflect over the y-axis, triangle ABC prime? Rotate 180 degrees, triangle ABC double prime, double prime, double prime, right? So we've seen it before, and then it's going to get used again to mean derivative in calculus. So I'm not a fan of that notation. The other notation that gets used, so this is going to be in your book. This is what this publisher does. The other one is to put not B. That little squiggle in front of it means not. So either B prime or not B. Now, look at the numbers that I threw on there. What is the complement of or not B? 1, 2, 3, 4, right? The stuff that's in the universal set, but not in B. So that's just an example. Element of versus contained in, that was an old typo. Contains. Contains. There we go. So like before, remember it was Olinda is an element of A. I couldn't flip that around. I couldn't say A is an element of Olinda because Olinda is a subset. Subsets can also be just one thing. Subsets can be empty. To flip that around and still be correct, I would write it as A contains Olinda. Now, Olinda might have problems with that, like, no one contains me. Get all fight. But that's the symbol for it, okay? Element of is this big loop here, a line in it to make it look like a goofy E. Contains is that big loop by itself, so it kind of looks like a big stretched out C. Okay, they're just different symbols. Now, this is all stuff that you should have seen somewhere along your journey before this class. Not everyone's had the same experience. Not everyone covers the same thing in their classes. Sometimes things get dropped. Sometimes the world implodes and education takes a giant crap. It should have been in geometry, yes. It should have been in geometry, at the end of geometry when you're dealing with probability and discrete math. Yep. I also know that our geometry teachers, I don't think they all cover this stuff because I'm not 100% sure it's in the Pearson books. You should have also seen it, get this, back in algebra half. Ancient times, right? So, and it's usually like one day in a passing, oh, hey, this is a symbol that you might see in math. And then they never use it again. So, don't feel bad if you don't recognize it. Okay, so here's how we're going to use it. Let U equal numbers. What is that? What are they defining? Universal set. Okay? And then A, B, C, D, and E are a bunch of subsets. So they're going to ask, state whether B contains A is true. Does the set B, does this contain all of that? No. False. Get the rest. Talk it out with your neighbors. Argue.
Because it's everything not. Oh wait, stop.
That's, yeah. 1, 2, 3, but also every not 6. Wait.
Find E prime. So that's all the numbers that aren't.
So, 0.
These are numbers going up to 9.
Oh wait, there's a 0. No, he has 3. So he has 3. Oh, he has 3. Yeah. So 80. So yeah.
0, 2, 3, 6.
ABC? Yeah.
Last group of freshmen, please report to the comments. If your name is T through Z, please report to the comments. Freshmen, last name T through Z. Thank you.
0, 2, 3, 6. Okay,
Okay, I want you all to stop and think about the conversations that you just had. Was it, no, it's this? Well, because you're dumb. Or was it, wait, no, this is over here, and this means complement of, so it's everything not in there. Didn't you have a more detailed explanation with it as you were having your conversation? Life lesson. You don't just argue by saying, no, my way is right. Don't you provide a reason? Don't you point to a determinable, verifiable fact like a definition? Don't you provide reasoning and then allow the other person to have input after you have provided that reasoning? That's how a conversation should go, not just in my class, not just in math, but in general. That's been lost in the last 5 years in a lot of places. So keep that up. I love the conversations that I'm hearing. This is great. Okay, what does this say? Oh, not complement, contains, right? E contains D. So does E have all of that? No. The complement of A. So everything that's not in A. Well, we got Missing 0, we have a 1. Missing a 2 and 3, got a 4, 5, missing a 6, got a 7, 8, 9. There you go. You just go through the universal set. Find the complement of D. The only things that D has are 2 and 3. So everything else in that universal set is complement of D. Okay. I ain't going to write it. There it is. Do that. Cool so far? Okay. They're not always written out like this. Instead, what you might see is written as Venn diagrams. Yeah, we'll probably do it this way. I'll hop in on here. Union, intersection, and empty set. These are all things that you should have seen before, again, but maybe it's been a while. Union is given by a big, it's like an oversized, little more junk in the trunk U. And it's the OR of the math world. A union of sets is anything that exists in one set or the other. So what's intersection going to be? And. And it's the same thing, but you flip it upside down. Empty set. I'm pretty sure we've seen that since the dawn of time because you used it to mean this doesn't have a solution. What does it look like? Ghostbusters. Right? It means nothing exists here. Literally an empty set. Now here's the other thing. I just write that. You do not write this because that's redundant. That's like calling some dude in a suit and tie Mr. Sir. This redundant statement is brought to you by the redundant Department of Redundancies.
Didn't they have that guy in Halls?
Probably. That was a really good movie. Actually, when I ran the group home, we had really gigantic like backyard area. This is in Arizona. So we're already kind of in the desert anyway. And they watched the movie Holes. And then all of a sudden, the one kid's just like, I want to dig a hole. All right, I had a shovel in the back of my truck. Here you go. Have fun. I kid you not. 5 weeks later, the owner of the company that ran the group homes came to visit and chewed us out because we had to fill everything back in for insurance hazards. Because these teenage boys effectively made their own prairie dog town out of the backyard. I'm talking like a kid my size, an 8th grader who was 6'1", 320, would be in that hole and you could only see this much of him. Like, I would get out of my college classes and get to work. And walk, where are they? Like, they just got back from school. Where are they? You know. All right, I walk in the backyard. Go! And I see all these heads. Whoop. Like, they'd make tunnels under actual compacted earth. Holes is a dangerous book. It gives kids ideas. Oh, here we go.
Name of H through C, please report to the comments. Again, seniors with the last name of A through C, please report to the comments.
Okay,
Also, any freshmen,
they're ahead of schedule, so we probably are going to hit the juniors here. Okay, again, universal set, 1 through 8, subsets R, S, and T. What is this asking for? Okay, we say it as R union S, and it means everything that is in R or S. So, everything that's in R or S, I see 2, 4, 5, 6, 7. There you go. So you just use the definition. Do the other two.
So it's R.
So do you like repeat numbers, right?
No, you do not repeat numbers. That's a good question. If you've said it once, you don't need to say it again. That's kind of like if I ask you who your best friends are and you say one kid twice, it gets awkward.
Oh, so it's 4 and 6? I think so. The same number.
Wait, no, there's a difference between or and in math. Remember?
Yeah, but
There's a difference between or and math and English. Or an and in English. There we go.
Fair.
If I say you want to go to the football game, Mom says you have to wash the dishes and clean your room. You only wash the dishes. You going?
No.
No.
It has to be in both sets.
There you go. Okay, or and have different meanings. One says any of the above, the other says has to be in both. How do I read this one? All right, you're off the hook. Y'all watch Despicable Me? Yeah, it's my wife. It's so fluffy. Anyway, how do I read that? R intersect S, and it's everything that has to be both in R and S. So what up here is in both R and S? There you go. What is in T and S? So I do that and I don't put brackets on it because that's redundant. Cool. Now, here's how this may be graphically. So far, these are all written out in list form. I'm not a fan of them only doing that, and then the assignment has Venn diagram style. So what you may see is more like this. R, S, T, okay, so we had T is only 1. We had R and S had a 4-6 overlap. That looks like 46. R had a 2. S had a 5 and a 7. What do I do with the 3 to show this as a Venn diagram? Just floating around out there. That's it. What else? 8. Okay, and you can put them wherever. It doesn't matter. Okay, so that's how it would be done visually. What if I added in some other numbers? What if I put in 0, 10, and 11? Okay, I'm just making stuff up. I just want to fill in some spots. Okay, so now what if I ask for a little more complicated of a set? What if I asked for not R intersect S? Whew! So the intersect in there means it has to be both of these things. So what numbers are there up there are in S, but they're not in R? 5, 7, and 11, right? Because we're looking at, here's all of S.
Picture, please. Seniors with the last name of D through H, please report to the Commons. Seniors with the last name of D through H.
I'm not allowed to be in R. So all these guys are out. Okay? I really recommend using some sort of like circle shading. I mean, that's me. I'm visual spatial. I recommend using something like that if you get these multi-component sets. Let's do another one. No, not you. You. Not you. You. There you go. All right. What if I did... Ooh, this one's always fun. T intersect S union. There's some gas on that curveball. Now what? Okay, so we'll start with parentheses, right? Just like order of operations. T and S. T and S. Okay. So that's this stuff. But then, or anything that's not an R. Or union isn't this, 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 and this also not an R. Okay? So I really recommend some form of like shading or visual representation when you're doing these if they get more complicated. Yep.
So 10 is in R.
Oh, yeah. We got to get rid of 10. Good job. What? What? Why? No, this. Yeah, you're right. You're right. Yes, it is. Because we started with here, right? And then we started with all this. Who's the exception right now? 10. You can't do that. It's in R. That'd be like, I'm going to invite all these people to my party unless you are friends with Caden. No, you ain't coming in my house. Like, but I'm like, we do Final Fantasy together every weekend. Like, what?
Next group
No,
of
get out of my
seniors
house.
to report to the office
You're friends with Caden.
will be E
Okay,
through
so
M.
that's why we got to get rid of that one.
With the last name of the E through M,
Not
please
bad.
report to the comments.
Where's my?
They
There
go
we go.
from freshmen to seniors? Yeah. Why?
They really shouldn't have done seniors first block anyway, because it's more likely that a senior has a first or fourth block free block. Like, that's right. This year's the first year that juniors were able to have free blocks.
Yeah, my next block is free block. Wait, no. That's on
I
my
have my next class and then I don't have any class for the rest of the day.
That's nice. Okay. So I just wanted to make sure that we went through that because it's not explicitly stated in the notes or the examples in the book. Already into 0-2. These first couple of sections we might double up sometimes because they're really easy. 0-2 is complex numbers. If we're talking about find before 0-2, go find like a blank corner area, something like that. Because I think before we go into this, we got to talk about the different number sets. In the beginning. Nope. In the beginning, there were these numbers. Naturals. Naturals may be referred to as counting numbers. I call them Arkansas math. Things that you can count on your fingers and toes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay? These are the numbers that you can physically count. That is the most basic of number sets. Naturals. Mm-mm. Yeah, that's too much. Like if they got a little nubbin right here, they're still going to count it. They're not going to say I've got 4.6 fingers over here. Okay. Does that nub really count? Okay. After that, someone was like, well, what if there's nothing? So then they said, these are the whole numbers. Whole numbers just adds in 0. That's the set symbol. They all are like a double vision version of a letter. So just double up. Like if you want to make whole, it's like, it's just kind of a literally double vision. Just double all the lines in the, okay. So we got whole numbers. Someone was like, well, what if there's nothing? Then along comes integers. This is where you got to negative numbers back in middle school. Okay, integers is a z. Integers goes negative 3, negative 2, negative 1, 0, 1, 2, 3. And we're going to have the ellipsis on both sides to show that it continues forever. These are positive and negative whole numbers. Now I want to see what y'all remember. What comes after integers? What if it's not a positive or negative whole number? Rationals. Okay. Next up comes rationals. Okay, now rationals got a little more oomph to them. That is real. Boy, I'm tired. Don't, not the whole thing. No. Screw you, Frank. All right, we'll go blue anyway. Rationals are done with a Q. Okay. What is a rational then? Anything that can be written as a fraction. Okay. So naturally, a fraction would be an example. Positive or negative. Would a whole number be irrational? Yeah. Because aren't natural numbers a subset of rationals? They're within it, yes. Okay, because I could just throw it over 1. What about a decimal that terminates? Okay, all the veterans who've been in my algebra 2 definitely remember this spiel, I hope. Okay, because a decimal that terminates, what place value is that 9 in? The thousandths. I can write that as 29 thousandths. So it's a fraction. Okay, I heard a repeating decimal. That is also true. Now, most of you are going to remember stuff like 0.33333. But what if I said 0.181818? No. There was an old trick you learned in middle school, and then they gave you calculators, and you stopped understanding it, or you just forgot it. The old trick in middle school is you take the part that's repeating. What part is repeating? 1/8. You put that many digits over that many nines. 1/8 over 9/9 reduces to 2/11. Now, if it's like 0.8333333, then you combine the two. You take the part that's repeating in that decimal place with the part that terminated, and you combine them.
Next group of
So that's a thing.
Through F, please report to the comments. seniors with the last name of N through F, please come to the comments.
Always separate your rational friends from your irrational friends. Okay? The friends that say, dude, have you ever paintballed cows? Like, my dad's got his old paintball gun. I found it in the basement, and dude, this weekend, right? Okay, take that friend and the friend who's like, maybe we should just play Halo, and separate them, because one of them's going to put you in jail and the other isn't. Irrationals. Irrational numbers are numbers that cannot be written as a fraction. What's an example of a number that just goes forever and never repeats? There's not a pattern to it. Okay, that's the one everyone knows. What's the one you were introduced to in Algebra 2? E. It's about 1.72 instead. It's the natural limit to a continuous growth. Yeah. I actually went to a debate. Like, okay, any of you watch Big Bang Theory, like the old episodes, like the first seasons? There was one where Sheldon and Leonard were trying to present something together, and they ended up like throwing physics yo mama jokes at each other, and then they started arguing, and they ended up in a slap fight on the floor. I saw that in real life. I went to a debate when I was in college between two math professors on the importance of pi versus e in the physical world. And they started throwing mathematical yo mama jokes at each other. And they got so heated, one of them actually threw something at the other guy, and then he walked off stage. Like, it's great. Like, pi happens so much when you're talking about physical objects. E happens so much when you're talking about natural growth and decay. Like, oh, I don't know, carbon dating, population growth. If I'm doing any sort of statistics, I'm going to want natural growth, continuous growth. What if I'm measuring the number of births of sets of twins in the United States? Does it happen periodically? Does it only happen once a year? Like, whoa, hey, slow down there. So, stop. I'm sorry, you can't have those twins yet. I need you to wait until March. But that's when our data collection is. As someone who was in the house with a woman who had 2 different kids, you get anywhere close to that due date and you say the words, maybe it's going to happen later, duck. Like, no, the things happen continuous. And that's what E is. Okay? Also, radicals. Smart 5. There's no pattern to that decimal. That's why we have to write things in simplified radicals. In fact, in this class, you learned all this stuff last year. In this class, decimals are like a forbidden language. Okay, unless you're talking about real world context. If I go into Necht Home Center and I say that I need 22 square root of 3 feet of 2x6, you know those guys are going to look at me like, huh, what? Right, that's just not going to happen. But if I were to instead tell them that I need at least 42 feet, okay, we're good. Like, they're fine, right? If you're dealing with a real-world context problem, you can give me the decimal equivalent after the expression. But everything else that we do in here, you're going to be accurate. You will write it in a simplified fraction, simplified radical, simplified terms of pi, I, and e. Okay? We write the real answer in here, not the decimal. Okay. No, that's what we're getting to. That's why we had to do this little side quest. Okay, all of this right now
The last group of seniors, please report to the comments. Last name of T through Z. Again, Seniors with the last name is T through Z, please report to the comments.
Okay, we'll do that. All of these are considered to be real numbers. They're real because I can find them on a number line. I can graph this exact location. And then, who comes along and joins the party? Imaginary. Imaginary numbers all have an I in them, which you learned last year as an extension of your quadratics. What is I? Square root of a -1. That is its definition. See, you can't take the square root of -1. If I say, what's the square root of 9? Or -3, thank you. Positive and -3, because I can take 3 by 3, or -3 by -3, and I get a 9. Square root is the operation that says what squared makes this number. Well, when you have positive and positive, makes positive. Negative and negative makes also positive. What times itself will ever make a negative number? Okay, so they came up with that idea. I is a symbol to represent that idea because it can't actually exist. When you use a symbol, when you start representing an idea, you can at least work with it. And that's what 0, 2 is about. It's the complex numbers. Okay? A complex number is written with a C, complex numbers. Complex numbers have a real part plus an imaginary part. Every number that you can think of is a complex number. Okay, if I had a strictly real number, 5. If I had a strictly imaginary number, 6i. A complex number would be 5 plus 6i, because it has both a real and imaginary component. So how do I turn just plain old 5 into a complex number without changing its value? What's it missing to be a complex number? An imaginary part. So how do I put an imaginary part here but not change its value?
Call for senior. Any senior who has not had their photo taken, please come to the comments. Last call for senior.
No? What is the additive identity? What can I add to anything to not change its identity? 0. So I can add 0i. What can I add to 6i to turn it into a complex number? A real 0. That's why every number you can think of is considered a complex number. That's why last year they stopped saying find all real and imaginary roots. Instead, they just said find all complex roots. Because complex encompasses both.
Next group of students will be juniors. If you have the last name of A through C.
They said they weren't going to get to that till 9:50.
Last name A through C.
Okay. A through C, get her done. So, I was also your first ring. And you're like, he gave me a promise ring. We're going to be together forever. No, no, no. A ring is a mathematical object. By the way, it's not going to happen. Okay? It's just not. Okay, I take that back. My little cousin's getting married. My little cousin's getting married this weekend. They have been dating since 5th grade.
Oh my god.
How adorable is that? Right? Okay, so I shouldn't say that. It can happen. But, no. A ring is a mathematical object. A ring is something that completes a cycle and comes back on itself. Such as I squared, I cubed, I to the 4th.
Wait. 5th grade?
Yeah.
So how does he act?
I think he just finished his accelerated OT program, so he's 22, 23.
Okay. At what point did he know? Was it in 5th grade? Yeah, he just got it.
I'ma marry you. Okay. Nah. Anyway. I represents the first ring because after I to the 4th, it repeats itself. So here's what I mean. If we take I squared, well, that's the square root of -1 squared. What happens when you square a square root? Right? Cancels out. You get the radicand. That's why this is -1. I to the 3rd. Well, if I break that up, remember your old exponent rules? You add exponents when multiplying. So 2 plus 1 is 3. This is I to the 3rd. Well, now I'm going to say that's -1 times I. So I'm just going to call it -I. I to the 4th. I'll just say that's a pair of I squareds. -1 by -1 is 1. So now I've completed the ring and I've hit I to the 4th is 1, is the identity. So what happens when I hit I to the 5th? I'll take I to the 4th with an I to the 4th with an I squared, I to the 4th with an I to the 3rd.
Juniors with the last name D through H, please report to the comments.
So that means every time that you hit an exponent divisible by 4, it resets the ring. So here's how this works. It's pretty slick. I is just I. I squared is -1. I to the 3rd is -I. I to the 4th is 1. But that also means I to the 5th is I. I to the 6th is -1. I to the 7th is -I. I to the 8th is 1. You should have. And it keeps going and going and going and going and going. Kitten calendar, right? It just goes forever. So if I said, what is I to the 37th? Do you really need to go around the ring that many times? Or can I turn that into I to the 36 times I, because I know that 36 is divisible by 4. So this is I to the 4th to the 9th power times I, which is 1 to the 9th times I, right? Wrong I, but cool. Wordplay. Oh, I thought you were agreeing with me saying I. Were you?
No.
No? You should have taken credit for it. Okay? So it's just going to keep going and going and going. This also works for negative exponents, too. What if I have I to the -91st? First of all, what's a negative exponent do? I remember? Flip the switch, goes downstairs. 1 over I to the 91st. Okay. So what is the nearest multiple of 4 right below 91?
88.
Okay. So that's 1 over I to the 88th times I to the 3rd. Cool? And I to the 88th is 1. So I've got 1 over I to the 3rd. Which is, and since I to the 3rd is a negative I, 1 over I, and I'll just throw the negative out front. Right? It's considered kind of improper to put a negative on denominator. Now, some teachers, some books are going to get lazy and leave it there. This is wrong. We learned a rule way back in Algebra 1. Remind me again what I is? Square root of negative 1. Why is this wrong? No radicals downstairs. They stir up the girls, give them bad ideas. I need to bring him upstairs where I keep an eye on him. You remember rationalizing? Yeah. Okay. So now I do all of this. Well, what is square root of negative 1 times square root of negative 1? Just a negative 1. Okay. So I got a negative. Negative 1 down here. We'll fix it later. I have 1 times, well, that's just I. A negative negative is positive. It's just I. I want you to look at how much work we just did. All completely unnecessary. Remember that I to any power that's divisible by 4 is 1. What's anything times 1? Itself. Multiplicative identity. Y'all gonna hate this. Think about it. Because 92 is divisible by 4. That means I to the 92nd is just 1. I took a thing times 1. So it's the same thing. But now, because I add exponents when I multiply exponents of the same base, negative 91 plus 92 is 1. Watch out, front row. Isn't that so much easier? Okay. So that said, when come on down here, I want you to simplify these two. All you got to do is multiply them by I to the some power that's divisible by 4, positive or negative, and it'll bring it down to that 1 through 4 ring.
Last name N through F, please report to the Commons. Juniors, last name of N through F, please report to the Commons.
I heard N through S.
They kind of skipped us. Okay.
F or N through S? They don't exist anymore. No, I don't need a picture of myself.
I mean, okay, you might as well go down there anyway, because they're just going to say at the end of all juniors, any junior who has not been called, come down. So just go. Yeah. Yes. Uh-huh. Okay. Too much, right? What is a number divisible by 4 that's really close to 53? 54 isn't. 52 is, right? So if I were to multiply this by I to the negative 52nd, right? So remember the ring goes this way by putting a negative. I'm just going to unwind the clock. And whenever I multiply exponents of the same base, I add the exponents. 53 minus 52 is 1. So I to the 53rd is just I.
That's confusing, but no.
Instead of having to say, all right, I to the 53rd. Now this is one way to do it. I'll do it differently. I could write I to the 53rd as I to the 52nd. Okay, Frank's starting to get cross-eyed again. Okay. I to the 53rd, I can call that I to the 52nd times I. Right? 52 plus 1 is 53. But since this is I to the 4th to the 14th, this is 1 to the 14th. 13? Oh yeah, it is 13. Yeah. So that's just 1 times I, so this is just I. What I'm saying is, you don't have to break it down like this. This is the way the book wants you to do it. You could just use a negative exponent with it and speed run. Yep, they all got to be multiples of 4, because every time you hit I to the 4th, I to the 8th, I to the 12th, I to the 16th, it's 1. And it repeats itself over and over and over. That's what makes it a ring. Okay. So I to the negative 18th. I could do all that business where I put it on the denominator, and then I clean it up, and then I rationalize. Or what if I take I to the negative 18th and I multiply it by I to some power that's divisible by 4 to bring it up into positive land? 20. Because exactly, right? If I only did it times I to the negative, or I to the 16th, it would still have I to a negative power. I don't want that. I want to be somewhere in that 1 through 4 area. So now this is I squared, which I know is negative 1. I love the self-advocacy. I want you to interrupt me when it doesn't make sense. I want you to ask questions. I want you to say, "Why? No, stop. Don't you dare erase that." Huh? I want you to do that. The more you do that, the better your educational experience is. Okay. I'm going to put 2 more up here just to be safe and get a little frisky with it. Let's go I to the 75th and I to the negative 131st. Okay. Y'all, you don't have to know the exact number. You could just use a number you understand and then work from there. Maybe I use, with that negative 131, maybe I start with I to the negative 20th, or 1/20th, because I know 120 is divisible by 4. You could start there and then work. But you don't have to go straight for the throat every time. Okay? I know it's Thursday, but it doesn't have to be throat punch Thursday. That ended up in my quote book before. A girl was like, "Hey, Kevin, it's throat punch Thursday." What? Just like, got him. In terms of color pie, that would be red-black.
I mean, it was pretty funny, I gotta say.
It was funny. In fact, red-black is called the Rakdos Guild, and they are carnival entertainers that seek to do everything they can to please their demon overlord through entertainment. Like literally the Rakdos, the leader of the guild, this giant like 9-story tall demon in fire. His flavor text is entertain me. It's great. Okay. I would say times I to the negative 72nd, calling it I to the third, which is negative I. I would call it times I to the 132nd, making it I to the first, which is just I. Okay? All right. So we got to make sure that we understand how the rings of I work so that we can start doing operations with them. I is just a symbol. The symbol has meaning. I can do things with it once simplified into that ring. But until it's simplified in that ring, I treat it like any other variable, which means I can perform operations with it. You learned this back in Algebra 2. If I see two complex numbers added together, then I just treat it like a variable. You combine the real part with the real part. You combine the imaginary part with the imaginary part. Alakazam. Real friends with real friends, imaginary friends with imaginary friends. If you try to put your imaginary friends with your real friends, you're not going to have any real friends. At least that's what Bill told me. I don't know. No, they're not laughing at you. Okay? When I multiply binomials, this goes all the way back to Algebra 1. You may remember FOIL, first, outer, inner, last. Maybe some of you were more like the rainbow kids, where you had to draw all of it. 2 by 7, 2 by negative 4i, negative 3i by 7.
Call for juniors. Please report to the comments if you have not had your picture taken. Last call for all juniors who have not had their picture taken. Please report to the comments.
Some of you might have done it like that. Maybe you did FOIL. Anyone like box method here? Punnett square style? Okay, there's some kids who that's just their jam. They would instead put 2 minus 3i here, 7 minus 4i here. Nope. Like that? You can do that. That's cool. So however you do it, however you multiply things, these are all just ways to distribute. They are different representations of distribution. That's all they are. But you combine your like terms, and I end up with 14 minus 10i plus 12i squared. Those are all like terms combined. But what can I still do?
How did you get 10i?
I did not see the 1. Like, I just straight up didn't see the 1. I didn't expect to have to do this on day 1. I didn't get to it yesterday. Mental health is a thing. I have a daily cap of 3 brownie points. Because after that, the little leprechaun that lives on my shoulder just starts screaming at me. You suck! You're stupid! You can't do anything right! And then it just all snowballs down from there. You know, that where you just have a bad day, and then you're just nicely hanging out in class, everything's great, and you just accidentally knock over your water bottle and pick it up quick, and then you stare at the puddle and start crying. Okay? Because that was just the last straw. I have found that if I cap it at 3 and just stop worrying about making mistakes, I don't make mistakes. But if I worry about making mistakes, I'm just going to make more. Cool? Okay. What can I still do to this? There you go. See, that's why we had to go through that ring business, because I have to remember that this is now a negative 12, because I squared is negative 1, which means these are actually like terms. So now I can say 2 minus 29i. Always separate your real friends from your imaginary friends. That's what is called a complex number. Real parts, imaginary parts. So, I do 2, you do 2. Get them. Okay, please remember when you are subtracting a thing to subtract all parts, might not be a bad idea to distribute a negative 1 instead. And then combine like terms. Right? Okay, down here after I do my distribution, your rainbow, your box, whatever it's going to be, we got 16 minus 20i plus 20i minus 25i squared. These are called conjugates. Conjugates are things that go together, binomials that have a different sign in the middle, because the middle term will always cancel. I squared is negative 1. This is 16 plus 25. Almost the meaning of life. Very close. Okay? Now, we're literally running like 3 minutes behind. So I'm going to finish this because we're so close. You all saw this back in Algebra 1 or Algebra 2. When I divide things, remember that I is a radical. No radicals downstairs. So if I were to multiply by I, well, it would get rid of this one, but now I'd have an I here, right? So multiply by the conjugate of the denominator. 1 plus 2i. So now upstairs, 5 plus 10i minus 3i minus 6i squared. Downstairs, 1 plus 2i minus 2i minus 4i squared. You use that idea that the conjugate will always cancel out the middle term. Because if I cancel out the middle term, and I'm left with an I squared, it's plus 4 now. So now I have all this junk over 5. I know that this is now a plus 6. And I know this is a plus 7i. Do not leave it like this. I know some teachers let you do this. I know some books leave it like this. I have so many kids who will come into my Algebra 2 or PreCalc, then go on and do a dual credit class that has online input. They will come in and slam their computer on my desk and say, why is this wrong? I have done this like 9 times. I know this is right. You taught me this way. This is right. And I say, separate your real friends from your imaginary friends. Because that's the appropriate way to write them. Okay? I won't, but I'm going to keep hammering on that. It needs to be written as a plus bi. Real part, coefficient of imaginary part. If you would please still do those, okay? Still finish those off so we have our complete set of notes and you get the practice to it. The assignment is already on Planbook. I got Prep Maroon too, so I'm going to be sending out the link for this video and the assignment on Remind. If you got any questions, wander down during Spartan time. Don't be bashful.